Hey guys, this is Patrick from STH, and today we're going to take a look at this system right here, which is one of the most awesome systems that we have taken a look at STH in a long time. Specifically, this is a 4-socket Cooper Lake system that let me just kind of give you some specs. First off, we have 4 CPUs in here with a total TDP that is now 1 kilowatts. Beyond that, to cool it, we have a total of 32 29,000 RPM fans, which is, well, why we don't have this thing running, because otherwise your ears would explode. And the other cool feature is that this has a total of 18 terabytes of memory capacity. And for those connectivity aficionados, this has a total of 192 PCIe Gen 3 lanes, and they're actually exposed in this system. And this system is the Gigabyte R292 4S1. There's also a 4S0 version of this, which we don't have, but it's really a GPU focused one. This really has more PCIe lanes, which is actually kind of cool itself. So in this video, we're going to talk a little bit about what in the heck is Cooper Lake, because you probably have never seen this first iteration of the 3rd generation Xeon Scalable before, but you've probably actually used it. We'll get to that in a little bit. After we talk about what Cooper Lake is, we're going to talk about this system from Gigabyte. And then finally, I want to talk about performance and power consumption. That's a lot to go over, so let's get to it. First off, we need to talk about what these processors are and what they're not. So these are 3rd generation Intel Xeon Scalable processors. There's a total of 4 of them in here. Now, 3rd generation Xeon Scalable will have 2 families. The first one is Cooper Lake, which that's what this is. And then there will be a 2021 Ice Lake version. I know some people are saying that it's not going to come out, but it definitely will come out not too long from now. And that's going to be the Ice Lake version. That's the 10 nanometer that brings PCIe Gen 4 and all that kind of goodness. Cooper Lake is still a 14 nanometer part that scales up to 28 cores, kind of like Cascade Lake does, but it adds 3 extraordinarily important features. The first big feature, and what really enables this entire system, is the fact that we go from a total of 3 UPI links on something like a Skylake or Cascade Lake processor up to 6 UPI links on each of these Cooper Lake processors. And what that practically means is that we can, if you have a 4-socket system like this, you can take your 6 UPI links and put 2 of them traced to each of these CPUs. And that gives you a total of 2 UPI links between each CPU, which gives you double the bandwidth of these Skylake and Cascade Lake generations that only had 3, so they only had 1 link between them. That is absolutely huge. It used to be when Skylake and Cascade Lake came out that you could have a dual socket system that would have all 3 UPI links connected, and that would give you a ton of bandwidth between the sockets. But then when you went to 4-socket, you only had 1, so you had like a third of that bandwidth. What's happened is that the Cascade Lake refresh basically made it so that way most people are deploying 2 UPI links between each socket, even in dual socket servers, and we get that same amount of bandwidth between all of these processors in a 4-socket configuration, which is really cool. The next major feature is Intel Optane PMEM 200. It used to be DC persistent memory, which I actually like kind of better, but we're calling it PMEM 200 now. Now, the new PMEM 200 generation still operates at DDR4 2666, and it goes in 128, 256, and 512 gig increments, but you do get more performance and over 20% more performance with the newer generation, and they have blue heat sinks, so that way you can tell them apart easily. And that is super important for a system like this because that gives us the ability to scale up to a total of 18 terabytes of memory. Each CPU has 6 channels of memory and you get 2 DIMMs per channel. So that gives you 12 DIMMs. So you get a total of 48 DIMM slots in the system. You could put all DRAM in them, but the other configuration, and I think something that is really the eye-opening one, is that you could put 256 gig DIMMs, plus you could add 512 gig PMEM 200 in there, and that gives you a total of 18 terabytes of memory. There is one major difference between this system and the upcoming Intel Ice Lake generation, and that's the PMEM 200 technically supports memory mode, where if you were to put that in here, you would see a fairly large memory footprint, I think like 12 terabytes or something like that. But in this configuration, you can only use it in app direct mode with Cooper Lake. Intel's marketing materials are not super clear on this, so we just want to clear that up, that you are going to be using app direct mode with this. And what basically app direct mode is it's the Optane DIMMs put into the memory channels and you get the persistence. So that means if you refresh or you reboot the server, you don't have to reload all of your data into memory. It's already there. That may not seem like a huge deal, but if you had something like a 12 terabyte data set that you're running SAP HANA on, that 12 terabytes can take a lot of time to go pull in off of the network, and so this is a much faster solution. The third major feature, and a very important one, is the fact that we get BrainFloat 16 or bfloat 16 support on this processor. Now, bfloat 16 support in the AI industry is super important because the industry is basically standardized on it because you get about twice the performance of FP32 if your processor supports it. And this one does, and that's for a really good reason. There are a couple other little features, such as you get higher clock speeds with this generation, and we still do have the L for the large memory versus the non-L for not the large memory in Cooper Lake. That's something that I think Intel will eventually change, but in Cooper Lake, the third generation Xeon Scalable Cooper Lake, you do still have that. Now, if you're watching this video, you might sit there and say, hey, I'm never going to use this, we don't use 4-socket servers, and so probably never going to use this processor, but you probably actually have. We covered on STH before that Facebook is actually using these Cooper Lake processors, and they have an entire architecture and infrastructure based on them, all the way from the single socket Yosemite nodes all the way up into the multi-socket nodes. While you're right that Cooper Lake probably is not going to be the most popular because the world is standardizing on 2-socket and also kind of 1-socket servers these days, at the same time, this is definitely a Facebook-derived processor, and you've probably used it because the Yosemite nodes are what Facebook uses to serve their front end. And going back to the feature set, the reason that bfloat 16 support is really important, or was really important in this processor, is because Facebook has just huge data sets, right? I mean, if you think about that model, they have giant data sets. And so they use the CPUs that they have in their infrastructure to be able to train some of these large models. And by having bfloat 16 support baked into the processor, they can use all of these compute resources that they already have and put those to use for AI training. And there are certain types of algorithms out there and models out there that require huge memory footprints that don't necessarily fit well on GPUs. So there still are a lot of areas in domain areas that Facebook works on that require that bfloat 16 support on CPU where you can have large memory footprints. Now, this server and this review has taken a long time to put together. When these chips were launched at the end of June 2020, it took us a long time for systems to be ready from all the major vendors, including Gigabyte, and Gigabyte managed to get us a system. And once we had a system, Intel said, okay, fine, we'll seed you guys and we'll get you some CPUs. So we got the server from Gigabyte, we got the CPUs from Intel, and then, we managed to scrounge up all the memory and all the other bits that we needed for the system. I can tell you that this took a lot longer to put together in terms of a review solution than a lot of the other servers that we put together. And I think the reason for that is, we have 12 processors and, so 3 sets of 4 for the system that have a total list price of over $100,000. We also are using a minimal configuration in terms of RAM, which is about 1.5 terabytes of memory. But let's get to the hardware. Now, the first thing that you're going to notice here is just the fact that this is a 2U system. It's 858 millimeters deep, and that's just shy of 34 inches. So if you have some smaller racks, you may have to just look around for PDU clearance issues, although these will most likely find homes in larger racks. But the other reason that I mention the depth is not just because of, do you have to worry about the racks, but actually Gigabyte did some things in the server to make sure that they could build a 2U server that could actually fit in even just 34 inches, because you can see that was definitely required some engineering challenge and prowess to be able to even do. Now, the key headline feature on the front of the system is most likely the 10 2.5-inch NVMe U.2 SSD base. Now, because we have a total of 4 processors and each has 48 PCIe lanes, that means that we have 192 total, which means that there's absolutely no problem giving direct access to these SSDs. We don't have to have PCIe switches or anything like that involved. There are a couple little features that I do want to point out, and specifically you're going to see that we have USB ports, but we also have another little slot on the front of this, and it turns out that that's actually an OCP, so PCIe Gen 3 by 16 OCP3 NIC slot on the front of the system. The OCP NIC 3.0 is going to be very popular in the coming months and years, and so it's kind of cool that you have it here. I don't necessarily like that it's on the front of the system. I probably would have preferred that it's on the rear of the system, but we're going to see what Gigabyte has in terms of connectivity when we get there. Something that you probably have noticed from the B-roll is that there are a ton of fans in this system. There's a total of 16 fans up front, and those sit below the NVMe SSDs. We're going to talk a little bit about what's going on in terms of cooling in a bit, But just note that those are there, and there is a nice little feature that Gigabyte has where you can unlatch the SSD cage and move it out of the way in case you do need to service. Now, just behind the fans and just below the connectivity for the NVMe SSDs, we actually start with the motherboard and we get right into the meat of it, which is we have the DIMM slots as well as the first 2 CPUs. We then move back and we have another 2 CPUs here and another set of DIMM slots. So we have a total of 48 DIMM slots and 4 sockets. This system uses the newer LGA 4189. So this is not the same LGA 3647 socket that was in Skylake and Cascade Lake. This is the newer version that will be similar to what's going to be in Ice Lake as well. This is socket P5, whereas Ice Lake will be socket P4. But in either case, if you want to see how to go do a CPU installation, including the heatsink in these systems, because it's a little bit tricky and a little bit different, we actually have a video on how to do that using this exact system right here. And so we'll link that in the description. In terms of CPU options, there's a pretty good scale. For example, we have 8-core Xeon Platinums, which are really designed for the per-core licensing market, where you don't necessarily need the most core count. You want to have a lot of high-frequency cores, and so we have that. We also have 2 different versions of the 28-core variant. So we have the 8376HL. L is for the large memory capacity. And then we also have the Xeon Platinum 8380Hs. Those Platinum 8380Hs actually have 28 cores, but they're 250 watt TDP CPUs. And that's actually what's in the system right now, which means that with 4 250 watt TDP CPUs, we have a total of 1 kilowatt of TDP. And of course, the system is going to use a lot more than that. We'll get to that in a bit. We already discussed the fact that this can take up to 18 terabytes of memory, and it really is designed for higher memory and also those Optane persistent memory workloads. I think those are going to be very prevalent in these 4-socket systems. Now, directly behind the CPUs, what we actually have is another fan partition, and these are 1U 29,000 RPM fans. Again, we have a total of 16 of them, and they just pop out of this little fan partition, and they're really easy to service. I really like this design by Gigabyte. I think this is a great job and is certainly far above what we've seen in the older generation Gigabyte servers. I really like this design. Now, if you're wondering about that heatsink design and you're saying like, hey, why are there like 2 different parts and 2 different levels for that? The partition and the fan and airflow guide that goes through this part of the system, actually you can see has 2 different sections. There's the bottom section, which takes air from the front fans and pushes those through that bottom section of the fan partition. And then there's the top portion of that, which uses these mid-plane fans and pulls air through the NVMe SSDs, through these fans, and then out to the I/O in the back. The other little feature that is kind of nice, it's just kind of cool, is the fact that these are copper heat sinks, and these are really nice copper heat sinks. I was very surprised by them. They look great, they feel great, and they're super heavy, and that really helps when you have to go cool a 250 watt TDP CPU, and specifically 4 of them in a server. On the motherboard itself, there are basically a couple features that we want to talk about in the rear. The first major feature is the fact that we do have an M.2 slot, so if you want to have M.2 storage for, say, like a boot drive, you can have that. It would have been nice if there were 2, but I guess that's what we get. Also, frankly, with 10 NVMe drives up front and also a ton of PCIe I/O over here, if you really want a second NVMe boot drive or another boot device, there are plenty of options for that. The PCH on this is the Intel 621A, which means this is a Lewisburg refresh PCH. This will be shared with the Ice Lake generation. So in terms of compatibility, you don't really have to worry as much about that because this is going to share the same platform controller hub with Intel's mainstream dual socket server for 2021. But that has implications for the rear I/O, so let's just get to that and then we'll come back to the PCIe slots. We have a management port, VGA port, COM port, we have USB ports, and then the other big feature is that you see 2 network ports, and those are Intel X710 NICs. But the interesting thing here is that with the Intel 621A and all of the refreshed Lewisburg PCHs, something that Intel did was they removed the 10G base T or 10GBE functionality from the PCH, and so we have to have an external controller to be able to power these 2 ports. To a lot of people buying these systems, you're going to end up using higher end NICs anyway, but you do have dual 10G base T NICs here. They are higher end IP from Intel, but at the end of the day, if you're going to build a system like this, most likely you're going to put 25 gig, 100 gig, or something like that into this solution rather than using the dual 10G base T on board. So let's get to the PCIe slots. Now there are a total of 3 risers, and there are a total of 8 PCIe Gen 3 by 16 slots in this system. There are 2 of those slots over each of the power supplies, and then there are 4 slots that sit on this middle riser that go in the center of this chassis. In fact, there are so many PCIe lanes that the connectivity for these PCIe slots is not just via the riser connector on the motherboard. Instead, we actually have to have these cables, and these cables are routed from the front CPUs back to the rear section where we have these risers. Because all of the PCIe routes are on the CPUs, we actually have to do and have to have cabling that goes from the front of the system to the rear of the system to be able to expose those PCIe lanes to slots that we can actually occupy. There are 4 major components to performance that I want to talk about. The first one we're going to talk about is just TDP. Now, part of the TDP limit is used for the memory controller, and part of it is also used for all of the UPI connectivity within the system, but the other part of the TDP is used for clock speed. We do get higher clock speeds on these parts than we do on the Cascade Lake and Skylake parts, and so therefore that kind of gives us the first part of our performance, which is we get higher clock speeds. These aren't necessarily like very different cores, and we're not talking about the bfloat 16 performance here, but just in terms of just general application performance, we do get better performance from this Cooper Lake parts than we do from the Cascade Lake parts, just because we have higher clock speeds. That's easy. The second major aspect of performance is the fact that we do get DDR4 3200 support in this system, whereas in the previous generation Cascade Lake, we would only get DDR4 2933. So let us be perfectly clear and concise in the fact that this Platinum 8380H is the highest performing 28-core CPU that you can get from Intel right now. You have the DDR4 3200 support, and you also have the higher TDP and higher clock speeds. So for publicly available SKUs, this is the high-end Intel part. Also, when we compare this to the previous generation, so the Skylake and Cascade Lake, say Platinum 8280, for example, this solution has twice the bandwidth between each of the sockets as the older generation. And that's just what I guess Facebook wanted and a lot of other folks wanted, because there was always a penalty when you moved from 2-socket to 4-socket. And this system really gets rid of that penalty. The final area of performance that I want to talk about is really thinking of this in terms of a radix. If you do have the power and ability to go and scale up into these larger nodes, one of the big benefits of it is just the fact that you need, say, fewer switch ports to be able to scale your number of systems. You don't necessarily just need fewer top of rack switch ports, but then that also means that you need fewer layers of aggregation, which lowers your overall latency, and it also lowers the overall power consumption for networking in your data center. You also potentially need fewer NICs, and so there are cost savings even in scaling up to a system like this. If you do need a cluster of systems to run big applications that have huge memory requirements, then moving up to something like this over a 2-socket server where you just simply can't hit that same memory capacity actually makes a lot of sense. Okay, so let's talk about power consumption. Yeah, this uses a lot of power. There's no way to get around it. I mean, the fact is that we have 1 kilowatt of TDP just worth of CPU. So the power supplies on here, depending on what voltage you're at, if you're at 240 volts, they can actually put out, I think, 3.2-ish kilowatts worth of power. Now, we didn't necessarily get anywhere near 3.2 kilowatts of power, but this is certainly not a 1 kilowatt configuration. And by the way, even with the lower end processors, you're just frankly not even this is going to be way over a kilowatt in terms of a system. We did have a configuration in this system where we were pushing that 2 kilowatt range because we had a lot of adding cards and what have you. And there is a GPU version, which of course, if you had GPUs in here, you would definitely be hitting that 2 kilowatts and more. If you had that configured, we just don't have, we have the 4S1 version, not the 4S0 version. So we don't necessarily have that same, I guess, kind of power density in the back as you would there. But that kind of brings us to the whole point of the system. This system is not designed to be a $2,500 fully configured or $5,000 fully configured server. This is definitely a high-end server. I mean, just the memory that we have in here is probably worth, say, $7,000. You also have 4 processors. You have a relatively lower volume system, and so overall, I mean, these systems are definitely 5 figures in terms of US dollars, and most likely a lot of configurations are going to hit that 6-figure range, and so that just kind of gives you some sense of these are not for low value just scale out applications. They're really for higher end applications. So while we talk about the fact that this system we got up to 2 kilowatts, it doesn't necessarily, I guess, in some ways, I guess it matters for planning and all that, those kind of purposes for a lot of organizations. But frankly, compared to the licensing cost for something like an SAP HANA that you would run on a system like this, the power costs are just basically a drop in the bucket. Let's just call it what it is. Before finishing our review of the system, I did want to talk about one just aspect, which is serviceability. Overall, I think that Gigabyte did a very good job. Everything in here is fairly easy to service. Most of the things like, these PCIe things, there's little latches. And so you have latches on the fans and everything here is actually pretty easy to service. But at the same time, this is a lot of components that are stuffed into a 2U system. So this is a massive server, even though it's only a 2U server. And because of that, there are little bits on here that I wish could be improved just a little bit. Putting 192 PCIe lanes in a system to work is no simple task, and that is why you have a lot of cabling in the system. At the same time, that cabling also makes it a little bit harder to service. For example, the airflow guide that goes through this part of the system, you do have to kind of move the NVMe storage tray out a little bit. You don't need tools to do it. It's not hard, but you do have to move it out of the way. I will say this was definitely not the easiest system, but it also just is the fact that you're scaling up in terms of complexity. And so there's a lot more going on, which means that there's more stuff crammed into a little space. And so I guess I should have expected that. But my personal opinion and my advice that I would give to our readers and those of you on YouTube is to just go buy the system fully configured from a vendor, make sure that it's all integrated, it's tested and validated before it hits your data center. I think that's the smart way to do it. I would not go buy this server as a bare bones and try to build it myself. I think that's just kind of too much of a pain. Have someone else do it that's a professional. You're just going to be happy that you spent the money. Now, this Gigabyte R292 4S1 is an absolutely awesome system. Just the fact that you can get all these PCIe lanes, all of the memory footprint, all of the cores, all into a system that's only 2U is, I think, just awesome, right? This is a scale-up system, and they always put a smile on my face. We've been doing these scale-up systems since the Xeon E7 V3 days, and we've been doing them every generation, and starting with Skylake and Cascade Lake, we've been doing multiple systems of each generation. And so I really like these systems because there's something that's a little bit different. And I know a lot of you that are reading STH or watching this on YouTube, you're going to see this and think like, hey, isn't Ice Lake coming out? And isn't that 3rd gen Xeon scalable? That is, but this is still going to be the 4-socket platform for Intel even after Ice Lake launches. It's actually just a different segment, and there's reasons behind that, which we'll go over when we can in our Ice Lake coverage. I hope you enjoyed this view of the server because I think it's absolutely super cool. And if you did, well, why don't you give us a like, click subscribe, turn on notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.